In the previous episode, we saw how extinction events often have an accelerating impact on recovery of all life forms since that point because of something called adaptive radiation, which I'll talk about in a minute. And that is why of the big extinction events that have happened in the Phanerozoic in the last 541 million years, the most recent was 66 million years ago, and that represented a major turnover in life on Earth. All of the dinosaurs that you see over here went extinct, and only the small subcategory of dinosaurs that we describe as birds today continued to exist after the 66 million year ago asteroid impact. But there was another extinction event due to two combined asteroid impacts about 34 million years ago, and that caused much, much less turnover in life, because not only are these mammals that we're seeing over here from the Cenozoic just as diverse as the dinosaurs before them, in some cases converging to very similar body shapes, the extinction event between the Eocene and Oligocene was not as pervasive because of the greater durability of life. And this is because multiple extinction events did enough of a robustification, if that's a word, of the processes of life to enable faster and faster recovery, because after each extinction event, we have something called adaptive radiation. That's an interesting sounding term, and what it means is that once there is a big extinction event and there is a vacuum, since nature hates a vacuum, evolution accelerates to fill all vacant niches, and that happens at a faster and faster rate each time. And that is why an asteroid extinction event, almost as big as the one 66 million years ago, happened 33 million years ago, but had a much, much smaller impact. It's not even one of the big 5 extinction events. Now, to illustrate this in more detail, we see this chart over here. This is the entirety of the Phanerozoic, the 5 big extinction events in yellow. And as you can see here, the big one was the one at the Permian Triassic. And as I said before, that was when life on Earth got as close as it ever got to going completely extinct, at least within the Phanerozoic. The Cretaceous-Paleogene extinction event 66 million years ago was much less dramatic. That was only a correction of this much, because the acceleration in the variety of genera was already underway, and not just because of the dinosaurs. This is across everything. Vertebrates, invertebrates, everything. From the most advanced to the most primitive life, the number of genera was already rising, and a huge asteroid impact could cause only a temporary correction in this, and the one that was 34 million years ago, the Eocene-Oligocene asteroid impacts, could do almost nothing. That's how much robustification in the variety and durability and elasticity of life had occurred. Looking at this same chart in another way, this is the same chart in genera, number of genera, and time before present, and it's segregated in terms of Cambrian genera such as trilobites, which were the dominant life form for a very long time, but then went completely extinct at the Permian Triassic extinction event. The closest relatives of trilobites that still exist today are horseshoe crabs, Paleozoic genera such as fish, and then modern genera. And you can see how the older ones are becoming less and less, and the more recent ones are becoming more and more. And again, this Permian Triassic extinction event was the biggest one. The Cretaceous-Paleogene was sharp, but very sharp recovery, and then it's almost impossible for a new extinction event to be that big after this. Down here we see families. So this upper chart is genera, lower chart is families, but a very similar pattern. Cambrian, Paleozoic, and modern families are segregated in terms of how long ago each evolved and how much of a part of the present they still are. For example, amphibians were once the dominant form of life on land, but since that was before this Permian Triassic extinction event, their extinction is something that they never recovered from. The vast majority of amphibians today are less than 1 kilogram in size. Very few are larger than that. And if they're larger than that, they are larger not by much. Whereas reptiles, mammals, and birds did not experience anything quite so dramatic. Reptiles somewhat, none of the reptiles alive today are nearly as big as the dinosaurs, but still, that's nothing compared to the extinction of amphibians that happened. And mammals just continue to diversify more and more, just like intelligence diversified. So even with families, the older types of families went away completely, almost, while newer ones become the majority, but the grand total keeps rising. And that same representation is also visible in this chart over here, which begins with the Cambrian explosion over here. As life evolved, more types of creatures came into existence, and the more advanced ones squeezed out the more primitive ones. There was an age of fishes when the most advanced and dominant type of life on Earth were fish. That was in the Carboniferous and Devonian periods. Then you had amphibians, and like I said, amphibians went extinct into very, very few types of amphibians, mostly very small. The age of reptiles, reptiles being more advanced. Then the mass extinction of dinosaurs, and therefore the only reptiles that still exist are these, and birds are also a category of dinosaur descendants that are listed as such and are from this reptile branch. And then you had mammals. For the longest time, you had mammal-like reptiles and synapsids and creatures like that. But then, once there was a vacuum, due to that asteroid impact 66 million years ago, the age of mammals comes into existence, and we have this tremendous diversification of life. And finally, intelligence arising from that. The age of man is the very last part over here. But notice how there is more durability due to adaptive radiation, and how equally dramatic asteroid impacts and other extinction events cause less and less damage and take less and less time to recover from. That is why something 34 million years ago, which might have been just as severe in terms of a disaster event as the one 66 million years ago, caused much less extinction. And even though 66 million years ago was a lot less than this one, even though there's no evidence that the asteroid impact or comet impact at the Permian-Triassic was necessarily any larger than the one at the Cretaceous-Paleogene 66 million years ago. Now lastly, we go to the evolution of intelligence, and now we're down to only 7 million years ago. So in the cosmic calendar, now we're talking about just the last few hours of December 31st. 7 million years ago, we had Sahelanthropus, which was the common ancestor of humans and chimpanzees. The human line broke away from chimpanzees about 5 million years ago. And this vertical axis is cranial capacity. Now, a human and a chimpanzee are roughly the same size, and I talk about prehistoric humans, not modern humans that have much better food and everything, but the type of humans that we might have seen in prehistoric times. The body size was not very different, but the brain size is very different. I speak about that at length in this video up here in this tag in the upper right hand corner, but as we see in this accelerating rate of change, this is now cranium size. We saw acceleration in evolution, but brain size is rising much faster than body size. And even though the rise was limited up to Homo habilis, which is this one over here, which is only 1.7 million years ago, then things just took off. Homo erectus had a brain of this size, and that's its skull. And then you have the two types of modern humans that existed very close to the present. Neanderthals, which went extinct, but their brain size was almost the same size as Homo sapiens. And Homo sapiens, meaning us, where the brain size is 1,500 cubic centimeters. So this exponential trend is the type of thing you would expect to see in a technology progression chart, but we see this in the evolution of brain size as well. And this happened in a very short time. We're talking the final minutes now of the cosmic calendar. So over 4 billion years of biological evolution, all those extinction events, the Phanerozoic was only 541 out of those 4.6 billion years, so just the final 12% of that entire progression. But this is too small of an amount of time to even see on those scales that we saw in earlier videos. And like I said, in the cosmic calendar, now we're talking the last couple of hours and the last minutes even of December 31st. Yet intelligence sprang up, seemingly by surprise. But if one understands the exponential rate of change and that Ray Kurzweil chart, it was not really that much of a surprise because the buildup was already occurring under the principles of the accelerating rate of change. And that is how intelligence came into being. Now, it came into being when it did because of the various adaptive radiation instances. Maybe intelligence would not have evolved when it did and would have been 5 million years later if not for those asteroid impacts at the Eocene-Oligocene extinction event level 34 million years ago that accelerated evolution, and maybe that's why we emerged when we did. or it might have been a little bit later. Or if there had been more impacts more recently, intelligence might have arrived sooner and from different ancestry than primates like we have experienced in our actual historical evolutionary trend. But since intelligence has emerged like this, we get into our human historical record. And that will be the topic of the next episode as we get closer to the present in our study of the accelerating rate of change. Thanks for watching.